Listen, I know. I'm out and you miss me. Madison, it's gonna be okay. Katie, it's gonna be all right. Christopher, it's gonna be all right. Ian, you get to go free today. Okay. Mariah, it's gonna be okay. Sadu, you'll live. And Jackson, you'll see me Monday. All right, now that I got that out of the way. Um, Word problems. These problems are found in your substitution notes on that was given to you the other day. What y'all gonna be mad about is the fact that you don't have the other notes that I'm gonna show you today. You gotta write all this stuff down. But know that I love you from the bottom of my heart. I do. And I cut the notes short so you don't have a lot to write. All right, so all we're doing, we're gonna set up these equations. We're not gonna solve for anything because some of these problems you'll have to solve a different way, and I'm not gonna teach that way until the latter part of the video. So find these word problems. Pause the video until you find them. Okay. A shopper purchased 8 khaki pants, 5 pairs of shoes for $220. The next day, he purchased 5 khaki pants and 1 pair of shoes for $112. How much does each pair of shoe and each pair of pants cost? So you don't know the shoes nor the pants. So those are your unknowns. So we're gonna just keep them P for, well, just, I hate using S. So this stupid message keeps popping up. I'm sorry, I'm gonna be upset and in my feelings because this thing keeps popping up. I don't know if I keep pressing something. All right, anyway, a pair of shoes, a pair of pants. All right, I'll make my S's fancy. Maybe I'll make them like a dollar sign. I don't know. All right, so S is for shoes. I put a little hook at the end. And then P, it looks like a swan. Y'all see the swan? Beast mode, son. All right, P is for pants. I should make that an extra credit question in next week's email to your parents. What did Mr. O'Neill say the S looked like? That might just be the one. I don't know. It's probably not because I told y'all already. All right, so what you don't know. All right, Miss O'Neill, shut up and get to the video because this is going to be long. All right, so we have 8 khaki pants, 5 pair of shoes for $220. So that's our first equation. We have 8 khaki pants, so 8 khaki pants, so 8P plus 5 pair of shoes, the S Swan, is $220. And then the next day he purchased 5 khaki pants and 1 pair of shoes. Shut up. For $112. So 5 khaki pants and then 1 pair of shoes for $112. So y'all, if we had to use substitution to solve this problem, what variable would we get alone? And this variable right there, we would get alone. And then we'll use substitution. As simple as that. We'll solve, and it'll turn out to be integers because we can't have half a pants, half shoes, all that good stuff. Let's look at the next one. A student bought 1 box of crayons and 5 reams of paper for $54. She bought 5 boxes of crayons and 3 reams of papers for $50. What is the total cost, or the cost of each box of crayons and each ream of paper? So we want to know the box of crayons and the ream of paper. So we can say C is for crayons because those are unknown, and P is for paper. So let's read it again. A student bought 1 box of crayons and 5 reams of paper for $54. 1 box of crayons, 5 reams of paper, $54. She bought 5 boxes of crayons, 5 boxes of crayons, and 3 reams of paper for $50. 5 boxes of crayons, 3 reams of paper for $50. So, if we were to use substitution to solve this, which variable would we solve for? C. Duh. It's sitting over there by itself. It's just like it's saying 5P, get away from me. Get out of my face. Go over there. Go over there. Go over there. And that's what we will do. Move it over there. All right, 2 more problems. And then we're moving on to the new lesson today. So, gosh, I feel for y'all. All right, I don't. If the length of a rectangle is twice the width and the perimeter of the rectangle is 30 centimeters, what is the length and the width of the rectangle? So, what do we not know? Our unknowns. L is for length. and W is for width. And this problem always jacks students up. I'm talking because I know some of y'all are still writing. Because they forget the perimeter formula. So the perimeter formula is P is equal to, leave me alone. P is equal to 2 times the length plus 2 times the width for a rectangle. So you don't have to draw this, but remember you have a rectangle and you have the length and the width, but there are 2 of them. So it's one over here and one over here. So it's 2 times the length, or it's going to be L plus W plus W, but while we do all of that. So we know that the length of the rectangle is twice the width. So how do we represent that? So we represent that by saying the length is 2 times the width. As simple as that, y'all. And the perimeter of the rectangle is 30. So we need to manipulate this equation right here and put 30 there. So we now have 2L plus 2W equals 30. What are the lengths and the widths? So now, y'all, we would use what? Substitution. The variable's already alone. No need to get L alone. It's already alone. And we'll put L right there. And we would solve if we had to solve this problem. That's how we would solve this problem. Okay? All right, last one. And then we're moving on to the new lesson. The population. Why am I moving this? The population of a city is 8,500. If the number of males is 820 more than the number of females, how many males and females are in the city? Males, females. M for males. F for females. So let's look at this. The population of this city is 8,500. So there is no male or females in this part. It's just assumed that we know that the population that we're talking about is made up of males and females. So how do we represent that as an equation? Come on. How do you represent that the population is 8,500? Well, you put the males plus the females. I don't think I gave y'all enough think time. Equals 8,500. It says if the males is 820 more than the number of females, how many males? So the males are, I like my M's. They look really fancy. They look really nice. My males are 820 more than the number of females. So more than means to add to. So 820 is added to the females. So females plus 820. And now we have a system. We would substitute this, because males is alone, right there. And we will solve, everybody. All right, y'all ready for the new lesson? Say yeah. You ready for the new lesson? Say yeah. If you're ready for the new lesson, say yeah, yeah. Yeah, yeah. All right. Elimination. We save elimination last because if we ever taught you elimination in the beginning, you would never use substitution or graphing to solve system of equations because elimination is that convenient. All right, so if I was in class, I would ask you, what does the word eliminate mean? And then some people would say to get rid of. Get rid of. Think of some words in fast. Somebody said to I'm trying not to say kill, but somebody always says kill. To kill off. To utterly destroy. That's what people have said in the past. So I'm thinking that Aiden Ivory would have raised his hand. Phoenix would have raised his hand. Sadu, Aniko, Lena. Who else would have raised their hand and said something? Maybe Talia would have said something like that. All right. So when both linear equations are ax plus by equals c in C form, omitting some rules of standard form, because some of these standard form rules are not going to apply, you can solve a system using elimination. You can add or subtract the equations to eliminate a variable. So let's get to the beginning part. Like we learned about what substitute mean. Now we're going to learn about what eliminates means. So 10 minutes in, I think I'm going to be just no more than 10 more minutes. That's what I'm thinking. Maybe 15 more minutes. All right. So if this is x and this is y, the question says, what would eliminate x? If this is a positive x, what would eliminate x? A negative x. Okay. What would eliminate y in this equation? A negative y. All right. I'm going somewhere. Stay with me. That's what they say in church all the time. I'm going somewhere. All right. What will eliminate x here? You get it. Negative 3x. I heard Ben say negative 3x, Mr. O'Neal. You know I got this. You know I got this. And then what will eliminate y right here? A positive 2y. Bella like, Mr. O'Neal, come on. Give me something harder. All right, whatever. Forget you too. All right, so that brings us to this. So we just, let me go back and read this. It says when both, sorry, you can't see that. Come on, man, stop playing games. All right, it says when both linear equations are in ax plus by form, omitting some of the rules of standard form, because we're going to see that sometimes your a is going to be negative and you might have a fraction. But if it's in this form, you can solve a system of equations by using elimination. Let's watch this magic, y'all. Y'all gonna be so mad at me. Mr. O'Neal, why you didn't teach us this at first? Why you didn't say Kennedy's like, Mr. O'Neal, Mr. O'Neal. All right, so the example is 5x minus 6y equals negative 32 and 3x plus 6y equals 48. Now, this is not in standard form because technically I could divide all of these by 3. That's just what it is. All right. So it's not in standard form, but it's in the form eliminating or omitting some of the rules. So the way we use elimination is to do this. We add vertically. That looks like vertically, but we add vertically. Okay. All right. So first, eliminate one variable. So when we look at here and we're adding vertically, that means I want to eliminate one of the variables. So what variable eliminates? If I look at 5x and 3x, negative 6y and 6y, the negative 6y and 6y eliminate. So when they eliminate, we just add vertically down. So 5x plus 3x is 8x. And 48 and negative 32 gives us a positive 16. So now what I do? I just solve for x. Yes, it's that easy. It starts off this easy. It gets harder, y'all. Don't even be mad. So we get x is equal to 2. All right. So this represents the x value of the ordered pair of the solution because the solution is where the lines intersect. So where am I putting this 2? Because I can't eliminate none. Everything's been eliminated. So where would I put this 2? Now I use substitution to put the 2 back into the easiest problem that I believe. So I'm going to put it here. All right, I'm gonna put it there, but I'm gonna show you that it works for anyone. So if I put the 2 here, 3 times 2 plus 6y equals 48. Stop it, go away. And I solve, I end up with, oh, I wrote that really fast. Okay, I'm sorry. And y'all don't, shoot, I just realized y'all don't have this. So, oh my God, I never said you don't have to write this down. Shoot, I'm sorry. I'm gonna say it on the announcement. I just realized that. So all that first part, you don't have to write down. And I don't want you to write down this because I'm showing you. I want you to just watch. Okay, my bad. Sorry. I'll put it in the announcement somehow, some way. All right, so if I put the 2 there, I get 3 times 2, which is 6, plus 6y is equal to 48. You're just watching me, so I can kind of flow. So now I solve for y by subtracting 6. Subtracting 6, we get 6y is equal to 42. Divide by 6, divide by 6, y is equal to 7. Okay, so I get the solution to be 2, 7. And if it's a solution, it should work for both problems. So when I put 2 right here, I should get the same thing. That's the whole purpose of the solution. So if I put it in this problem right here, 5 times 2 minus 6y equals 32. I get 5 times 2, which is 10, minus 6y equals 32. I subtract 10 from both sides. I get negative 6y is equal to, oh, what did I do wrong? Hold on. Hold on. Hold on. Hold on. All right, just realized what I did. Forgot my negative. I was like, hold up, I did something wrong. Forgot my negative. So we end up with negative 42 divided by negative 6 divided by negative 6. Y, I was about to say, this is not a solution, is equal to 7. So let's review this again. We will first eliminate one of the variables, and then we'll solve for the other variable. So we got x equals 2. And then we plug that 2 into the easiest problem. I would have preferred this problem because the 3 is smaller than the 5. That's the only reason why I would prefer that problem. And then we solve for the other variable. All right, so I'm 5 minutes in to my 15 minutes. So technically, I got 10 minutes left with y'all, supposedly. We'll see how that goes. All right, so this is what I do want you to write down. So if you pause the video, write down these 3 problems. We're going to solve them together. All right, write down these 3 problems. This is problem 1. This is problem 2. This is problem 3 on line paper somewhere. All right, I'm sorry. I know you would be given this. I spoil y'all. So, okay, you're welcome. All right, so we look and see in the problem, do we have anything able to eliminate? Yes, what eliminates? The x's. So the x's will eliminate. And when they eliminate, I am now left with y minus 5y, which is negative 4y, is equal to, remember we add down, combine down, 5 minus 9, which is negative 4. So now we divide by 4, negative 4 divided by negative 4, we get y to be 1. Now some of y'all will be like, I got this, Mr. Owen, I don't need to watch this video, and just go back and just fast forward and just make sure you got the same answers that I got. That's fine with me. Whatever, Melvin, do your thing. I don't care. Who else will do that? Zaria, do your thing. I'm not mad at you. Who cares? I don't care. Do your thing. All right, now we are going to put this y into the easiest problem. I like the first problem, so I'm going to put this y right here. Sometimes I like the second problem because the x is not negative, but whatever. I like the first problem. So I end up with negative x plus 1 is equal to 5. Then now I subtract 1 from both sides. I get negative x is equal to 4. Divide by negative 1. And we get x is equal to negative 4. So what is the solution? 4, 1. Negative 4, Mr. O'Neill. 1 is the solution. All right, let's look at the next one. So do we have any variables to cancel out? Yes, these y's cancel out. So now I combine the x's. So x and x make 2x, and 12 and 2 make 14. Divide by 2, x is equal to 7. Where is this going? Into the easiest problem that I believe. I like the first one because it doesn't have a negative sign, so I'm going to put it there. So I get 7 plus y equals 12. All right, so I subtract 7 from both sides, I get y is equal to 5. And there you have it, y'all. Okay, let's look at this one. So do we have any other variables eliminate? Yes, these 5s eliminate, these y's I should say. I forgot to put my, go over there. Let's not be different this time. So 2x plus 3x gives me 5x. And then negative 24 plus 14 gives me negative 10. And now I have divide by 5, x equals negative 2. And I put that into the easiest problem. I like the 2 because it's smaller than the 3. So 2 times negative 2 plus 5y equals negative 24. Maybe I would have liked the 14 and not deal with this negative 24. Whatever. So now 2 times negative 2 gives me negative 4 plus 5y equals negative 24. Add 4 to both sides. Stop it. Add 4 to both sides. Got some haters, man. It's 2020. And we get a negative 20. Divide by 5, y is equal to a negative 4. So what's the solution, everybody? Negative 2, negative 4. Sounds like Alberto. So what does this mean? This is the place where the lines intersect, right? Right, D? Okay, all right. Right, Christian? This is the place, Isaac, this is the place where the lines intersect. All right. I need to stop calling names. If somebody's name I can call, they'll be like, I knew he'd like me. I should have wrote his review that he was a hater. He has favorites. He don't like me. He don't like me. I don't care what you think. I do care what y'all think. Y'all are why I do what I do. Why I make videos. All right. Yeah. So that's example 1. All right, y'all, we got like 5 more minutes left. I think I can do this in 5 minutes. 25-minute video, that ain't bad. You know what I'm saying? You got like 20 more minutes left of class if you didn't doing your things like you're supposed to. At least 20 minutes left of class left. So let's look at example 2. Example 2, you know you don't have to write this down. You're watching me. Example 2. So what happens, y'all, when I get a system like this that's in standard form, semi-standard form, that's what we'll call it, semi-standard form, and nothing eliminates. Y'all see these x's? These x's don't eliminate because one is positive and the other is positive. We now know in order for something to eliminate, it has to be the opposite of each other. So it's not the opposite. So we have to think about it. So mathematically, what would we do so it can be the opposite? We want to change the sign. One of these need to be negative. So mathematically, this is what we do. We change, I want to go over here, change the sign of everything in the problem to cancel. And how do we do that? We change the sign of it by multiplying everything by a -1. So if I want, it doesn't matter which one you like to be negative. I usually choose the bottom because I just like just the flow to go from the top to bottom. So I always make the bottom one negative so that it just flows that way. You know, I don't know. It doesn't matter because I just want one of the signs to be negative. So these x's, these are prime candidates to be canceled out. So I choose them to be canceled out because they're the same number. They just need to be opposites. And the way they become now opposite is that one is positive, one is negative. So multiply everything by a -1. Okay? And so when you do that, you distribute, or do I do the top? I usually do the top. Sorry. You'll see in a second my method. Okay, whatever. I did the bottom here because I didn't do all this work. So multiply everything by -1. And you know, multiplying everything by -1 changes the signs. So we get -x plus 4y equals -14. And now they cancel. We add like normal. 7y is equal to a -7. Divide both sides by 7, though you didn't see that. Y is equal to -1. Now we pick the easiest problem to put this into. I chose this problem right here. Substitute it there, and we end up with x equals 10. And so the solution is 10, -1. What does this mean? What does this mean? This means this is the place where the lines intersect. Yes, yes, yes. Y'all, I think I can do this in like 3 minutes, maybe. Probably not. Maybe like 5 more minutes, whatever. I'm gonna be 2 minutes over. Okay, so solve each system by using elimination. So y'all see this example 2? All right, so you see that, right? So example 2 says that we have prime candidates for elimination. You do need to write these. So take a moment and write these problems down. Write them down, 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 write them down. So we have prime candidates for elimination. Those would be those x's. So what I would do, I would multiply. I think I do the top because I like just bringing it underneath. That's exactly what I do. I multiply the top by -1 so I can just bring it right underneath here and just eliminate them. Okay, so if I multiply the top by -1, I get a -x, and then negative times that will be a positive 10y, and then a negative times that will be a -60. Okay? So I'm only looking at this section right here, everybody, because I don't want folks to get confused. I'm only looking at this because I've transformed this problem to look like that. All right, so these x's are now going to cancel. Prime to candidates are now out, and we got 14y plus 10y gives us 24y, and then 12 minus 60 is a -48. Divide by 24, divide by 24, and we get y to be a -2. So where can you plug this in? So this is the magic thing. This equation, this y equals -2 can go here, it can go here, and it can go here. You choose where you want it to go. I never like dealing with negative x's, so I am just going to simply substitute it into the second problem because I just like the second problem, the middle problem. So we have x plus 14 times negative 2 equals 12. So we now have x. 14 times negative 2 is negative 28 is equal to 12. We add 28 to both sides, add 28 to both sides. We get x is equal to 40. So our solution is 40, negative 2. What does that mean, Courtney? What does it mean? All right. I knew you knew. I heard you. All right, prime candidates. Who are our prime candidates? Y'all, I've never said that term. That's why I need to make more videos, because stuff come out of me that I don't say in class, and I'm just like, I've been teaching for 12 years and I've never said that. And it just makes more sense. It allows y'all to hone in on who needs to cancel out. So do we need to cancel out the X's or the Y's? Well, the prime candidates will be the X's. All right, get out of here. And the way we do that, we need to, what? 1 needs to be the opposite sign. So we're going to multiply the top by a negative 1. And when we do that, we get a negative 5x minus y equals 0. So I'm only looking at these two problems, right? So these 5's cancel, the x's cancel, and 2 minus y is 2y minus y is y, and 30, plus 0 is 30. Y'all heard me about to say 0? Because I was thinking about multiplying. Math competence, Mr. O'Neill. All right, and then we're going to put this into the easiest problem. That's a 0 right there. I like 0 problems. So we're going to put you right there, buddy. You go right there, man. You go right there. So we get 5x plus 30 is equal to 0. We subtract 30 from both sides. How am I doing on time? All right, I'm doing pretty good. 5x is equal to negative 30. Y'all feedback said I go too fast sometimes, so I'm trying to slow down. I listen to y'all. I care about y'all. I care about y'all grades. I want y'all to be great. You know what I'm saying? Because y'all are amazing. Y'all get them on nerves from time to time. But y'all are really good kids. Guess I'm being sentimental. I don't know. Oh, gosh. My kids are amazing. They work so hard. They do so much. Everybody but Nico. Oh, gosh. All right. So, let's look at this last one. So, notice that we still have same signs. Who's the prime candidate? Clearly these X's. I mean, I must be hating on these X's. Bye. That's like an X. Goodbye. I need to make some other people. Zaria needs a little boo. Zaria has a little boo in the class. They're going crazy now listening to this. Got a little X boo. All right, I'm leaving it alone. All right, so negative 5x and negative 5x, they need to go, right? Because they're the same sign. If one was positive, then they would cancel. So let's make them one of these positive. Let's make the top positive by doing what? Multiplying by negative 1. So we multiply by negative 1, we get 5x minus 7y is equal to negative 11. Y'all know how many people forget about that. They just be hating on that c over there. Ax plus by equals c. Don't hate on the c. You're going to see. I couldn't come up with nothing from the top of my head. C, you're going to be wrong. Aha! Got it. Bullard laughed. All right, so now these cancel. And we end up with negative 4y is equal to 8. Divide by negative 4, divide by negative 4. Y is equal to negative 2. I know you got that, Ainsley. I'm so proud of you. I know you got that, Cammy. So proud of you. So, Ben, look at you, Ben. All right, and now we put this up here. Y equals negative 2. I'm just going to put it right there because I want to even. I'm at even. I want a positive number. So 5x and then negative 7 times negative 2 equals 19. So 5x plus 14 equals 19. I am going a little fast right now because I know y'all know how to solve these problems. It's a two-step equation. It's equal to 5 divided by 5. AJ's with me. AJ's like, I've been waiting for you to go fast all the time, Mr. O'Neill. AJ always got something to say. Sir Malachi was like, I never knew I can do it, but now I believe, Mr. O'Neill. I don't know why I'm so silly tonight. All right, so we get y equals, the solution is 1, negative 2. 1 negative 2 is the solution. Oh my gosh, it's almost 30 minutes in the video. I think I did amazing. I think I did wonderful. I am wonderful, you know, whether you think so or not. I know I am. I know I am. I know you miss me. All right, talk to you later. Have a great life. Mr. O'Neill, I'm out. Yeah, I think I'm out. Yeah, I'm gone.